hides more than we see. Every layer, every shadow, every silent corner holds a truth we haven't fully understood. These aren't fantasies. They're real scientific puzzles still unfolding. Let's uncover them one by one. Chapter 1. Beneath Earth's crust lies a hidden world of locked oceans trapped in mineral crystals. Scientists found ringwoodite carrying water 3 times more than all surface seas. This means Earth might be a layered water planet, quietly recycling oceans through deep mantle currents. The idea reshapes how we see life's stability, hinting that our planet guards vast reserves, waiting for the right moment to reveal their story. Chapter 2. Earth's magnetic field isn't a stable shield. It flips, wanders, and weakens without warning. Deep in the liquid iron core, swirling currents generate chaotic pulses that shift our protective bubble. Ancient rocks record these reversals like forgotten messages. Some flips nearly collapse the field entirely. Yet life continued, suggesting resilience even during cosmic exposure. Earth silently negotiates with space, balancing chaos and survival. Chapter 3. Under Antarctica's ice, a vast canyon system rivals the Grand Canyon. It's carved by ancient rivers that flowed before the continent froze. Radar scans reveal hidden valleys, mountains, and entire drainage networks still shaping ice movement today. These frozen landscapes hold climate timelines stretching millions of years. Every layer captures atmospheric secrets like pages in a cold archive. Antarctica hides Earth's memory beneath its quiet surface. Chapter 4. Earth hums with a constant vibration, even without earthquakes. This steady resonance, called the microseism, comes from oceans pushing against continental shelves. It travels through the crust like a heartbeat. Scientists use it to map underground structures without drilling. The hum whispers about magma chambers, fault lines, and hidden voids. It's the planet talking in low frequency, revealing its shape through subtle rhythmic signals. Chapter 5. Near the ocean floor lie brine pools, dense underwater lakes that trap anything entering them. Their chemistry resembles alien worlds, toxic, oxygen-free, and rich in heavy metals. Yet life thrives at the edges, adapting to conditions once thought impossible. These pools demonstrate how extreme environments can support biology, offering clues for life on icy moons. Earth hides blueprints for survival in places almost unreachable. Chapter 6. Lightning strikes Earth about 4 million times a day, but some bolts never reach the ground. They shoot upward into the stratosphere as red sprites, blue jets, and elf rings. These rare electrical bursts reveal how storms interact with mere space. High-speed cameras only recently captured their true shape. They hint that Earth's atmosphere is more connected than we assumed, forming a tower between ground and cosmos. Chapter 7. Earth's core rotates at a slightly different speed than the planet's surface. Its iron sphere drifts by fractions of degrees, occasionally slowing or reversing. Chapter 8. Deep below the Amazon lies the river Hamza, a massive underground stream flowing thousands of kilometers beneath the basin. It moves slowly, carrying warm, mineral-rich water through porous rock. This hidden river alters pressure patterns, affecting surface ecosystems without being seen. Its discovery showed that Earth's hydrology extends far beyond surface maps. The planet runs multiple water systems at once, each shaping climate quietly. Chapter 9. Earth stores ancient forests inside coal seams where leaves, spores, and insects remain perfectly pressed. These coal forests capture entire ecosystems that vanished during mass extinctions. Some fossils show tree stumps still rooted in place, frozen in time by sudden burial. They reveal rapid environmental shifts and how life adapted or collapsed. Earth keeps these silent records to show how quickly stability can break. Chapter 10. Our planet glows at night beyond city lights. The atmosphere releases faint natural luminescence called airglow, created by chemical reactions in high altitudes. It paints green, red, and purple layers invisible to most eyes. Satellites track this glow to study temperature patterns and wave movements across the upper sky. Airglow proves Earth is never truly dark. It radiates quiet colors even in emptiness. Chapter 11. Beneath southern Africa and the Pacific sit two giant mantle structures, each the size of continents. They're hotter and denser than surrounding rock, rising like buried mountains. These hidden anomalies may drive volcanic hotspots and even affect plate motion. Their shapes shift over millions of years, acting like slow geological engines. Earth holds these massive forms deep below, influencing the surface without ever being seen. Chapter 12. Some lakes breathe. Lake Nyos in Cameroon once released a massive cloud of carbon dioxide stored at its bottom. The gas surged out silently, flowing like a deadly fog across villages. Scientists later discovered similar limnic lakes worldwide, holding pressurized gases in deep layers. These hidden pockets form through volcanic leaks. Earth stores these invisible dangers quietly, waiting for disturbances to break their still surfaces. Chapter 13. Earth's crust floats on a soft, shifting mantle, but parts of it sink like anchors. These slabs, once ocean floors, dive into the mantle where they crumble and melt. Seismic imaging shows entire continents' worth of crust stacked deep below Asia. These fossil plates reveal past ocean shapes and continental drift patterns. Earth keeps old worlds pressed beneath new ones, recycling geography over eons. Chapter 14. In deserts, stones move on their own. Racetrack Playa in California shows long trails behind sliding rocks. Chapter 15. Volcanoes can erupt under glaciers without breaking the surface. These subglacial eruptions melt massive ice cavities, creating hidden lakes and sudden floods. Iceland's landscape is full of these secret events, shaping valleys and plains beneath frozen caps. The water bursts carve new routes in hours. Earth hides fire under ice, letting two extremes meet and transform the land through quiet, powerful interactions. Chapter 16. Millions of microfossils fall from the sky each year, tiny life fragments carried by winds from distant oceans. These particles help seed clouds, cool the atmosphere, and fertilize soils. They travel across continents, joining global cycles unnoticed. Scientists find them in ice cores, deserts, and mountaintops. Earth spreads life in invisible ways, letting microscopic travelers shape ecosystems far from their origins. Chapter 17. At the bottom of the Mariana Trench, immense pressure turns sediments into strange metallic clays. These materials conduct electricity differently, hinting at chemical reactions not seen on the surface. Life survives here using simple molecules as energy without sunlight. These deep ecosystems resemble ancient Earth and possibly other worlds. the trench keeps hidden experiments running continuously in the planet's darkest laboratory. Chapter 18. Earth's rotation slowly stretches the day. Atomic clocks show that days get longer by milliseconds each century. Tidal forces from the moon pull in oceans, slowing the spin. Ancient coral rings record shorter days from millions of years ago. As Earth continues aging, this process never stops. The planet quietly expands time, revealing that even something as constant as a day is always shifting. Chapter 19. Sinkholes appear suddenly, but their roots grow for centuries underground. Water dissolves limestone until ceilings collapse, forming deep vertical chambers. Some sinkholes become gateways to untouched ecosystems, with species isolated for millennia. Mexico's cenotes hold ancient bones, artifacts, and clear blue waters unseen from the surface. Earth hides entire worlds below ground, waiting for a single break to reveal their depth. Chapter 20. Beneath Siberia's permafrost lie preserved creatures from extinct eras, mammoths, woolly rhinos, even Ice Age plants still intact. Frozen in crystalline ice, their tissues reveal DNA sequences and ancient diseases. These remains offer glimpses into lost ecosystems and climate cycles. As temperatures shift, more emerge from melting ground. Earth stores whole chapters of evolution in frozen vaults, opening them slowly as conditions change. Chapter 21. Earth's atmosphere forms invisible gravity waves that ripple across the sky. These waves aren't like sound or light. They're shifts in air density triggered by storms, mountains, or ocean winds. Satellites capture them as faint patterns drifting for thousands of kilometers. They help distribute energy around the planet, shaping jet streams and weather cycles. Earth constantly breathes through these hidden atmospheric pulses. Chapter 22. Hidden caves beneath Australia hold ancient microbial colonies glowing faint blue-green. These organisms survive on minerals, not sunlight, forming mats that resemble early Earth life. Their pigments react to moisture and trace elements, creating dim bioluminescent patches. Scientists study them to understand how life started in darkness. Earth stores these living fossils underground, quietly preserving clues to its earliest biology. Chapter 23. Under the Sahara lies a network of buried rivers and green valleys from a wetter past. Radar mapping shows channels where hippos and crocodiles once roamed. These fossil landscapes reveal cycles of climate shifts, swinging from desert to grassland repeatedly. Some underground aquifers formed from ancient rainfall still supply communities today. Earth hides its former identities beneath sand, reminding us how quickly environments can transform. Chapter 24. Earth produces natural glass through lightning strikes, meteor impacts, and volcanic blasts. These glasses trap microscopic Chapter 25. Below Yellowstone sits a massive magma reservoir stretching far beyond the visible geysers. It's not a single chamber, but a complex system of molten and semi-molten rock linked by hot conduits. Seismic waves show it pulsing like a slow heartbeat. Though it won't erupt anytime soon, its heat drives surface chemistry, geyser rhythms, and mineral cycles. Earth's fiery engines work quietly, shaping landscapes from below. Chapter 26. Earth's oceans hide underwater volcano chains that form islands over millions of years. These hotspots move as tectonic plates drift, creating trails like the Hawaiian Emperor Cenote Line. Each extinct peak records a moment in Earth's shifting crust. The bends in these chains reveal changes in plate direction. Earth writes its tectonic history on the ocean floor, stacking extinct mountains out of sight. Chapter 29. Salt flats like Bolivia's Salar de Uyuni hide lithium-rich brines beneath their crust. These brines form from ancient lakes that evaporated slowly, concentrating minerals over millennia. The flat surface acts as a giant natural mirror, reflecting the sky almost perfectly. Underneath lies a resource shaping modern technology. Earth stores valuable elements in quiet, reflective landscapes most people only see from above. Chapter 30. Earth's orbit slightly oscillates over long cycles, altering sunlight distribution across latitudes. These Milankovitch cycles drive ice ages and warm periods. Evidence appears in ocean sediments showing rhythmic layers of microscopic shells. The planet's climate dances to these orbital patterns, shifting slowly but powerfully. Earth hides its long-term climate rhythms in celestial mechanics, influencing global environments without direct visibility. Chapter 31. Deep beneath Mexico, the Cave of Crystals holds some of the largest natural crystals on Earth. These gypsum giants grew slowly in a chamber filled with mineral-rich water at stable temperatures for hundreds of thousands of years. Their structures contain fluid pockets, trapping ancient microbes and chemical traces. The cave shows how extreme stability can build enormous forms. Earth hides slow-growing wonders that require perfect conditions to exist. Chapter 32. Beneath the Arctic Ocean lies a layer of methane hydrates, ice-like structures trapping massive amounts of methane gas. They form under pressure and low temperatures, locking carbon in frozen cages. When disturbed, they can release gas rapidly, influencing climate patterns. These deposits record long-term climate shifts and ocean chemistry. Earth stores powerful greenhouse gases in quiet reservoirs, balancing delicate conditions that regulate the planet's temperature. Chapter 33. The Amazon rainforest creates its own rain through massive water vapor cycles. Trees release moisture that rises, condenses, and returns as rainfall. Satellite data shows billions of liters recycled daily. This system stabilizes regional climate and helps form atmospheric rivers flowing across continents. Even in silence, forests act as climate engines. Earth embeds complex feedback loops in natural systems, allowing ecosystems to shape the sky itself. Chapter 34. In Greenland's ice sheet, scientists discovered huge melt channels flowing like rivers beneath the surface. These hidden currents carve tunnels, reshape glaciers, and speed ice movement toward the ocean. Radar imaging reveals shifting networks responding to seasonal temperature changes. The water creates slippery bases, accelerating glacier flow. Earth hides powerful processes inside ice, where liquid and solid interact to influence global sea levels. Chapter 35. Some mountains rise faster than erosion can flatten them. The Himalayas, formed by India's collision with Asia, still grow as plates push together. GPS data shows upward movement each year. Inside their rocks lie clues about ancient oceans that once separated continents. These mountains hold fossils from seabeds lifted to extreme heights. Earth folds and lifts old worlds into new landscapes, preserving deep history in towering layers. Chapter 36. Earth's deepest gold deposits formed from ancient superheated fluids circulating through fractures. These fluids carried dissolved metals that crystallized under pressure. Some mines reach ecosystems thriving on chemical reactions rather than sunlight. Microbes use tiny amounts of hydrogen and sulfur for survival. These organisms reveal alternative forms of life. Earth hides biological diversity inside mineral-rich zones far from typical environments. Chapter 37. In deserts, dust storms carry fine particles across oceans, fertilizing distant ecosystems. Sahara dust travels thousands of kilometers to feed the Amazon soil with phosphorus. Satellite tracking shows these dust plumes linking continents. They influence ocean productivity, cloud behavior, and nutrient cycles. Earth connects distant regions through airborne bridges, demonstrating that even lifeless sands play roles in global ecology. Chapter 38. Under Japan, molten rock forms intricate mush zones, regions neither fully solid nor liquid. These zones can feed volcanic eruptions or remain dormant for centuries. Seismic waves reveal their textures like blurred images beneath the crust. Their behavior affects eruption styles and magma movement. Earth stores these half-melted layers as transitional states, shaping volcanic processes in ways still being understood through modern imaging. Chapter 39. Lake Vostok in Antarctica lies sealed beneath kilometers of ice, untouched for millions of years. Its water remains liquid from geothermal heat below. The lake may host isolated microbial life adapted to extreme darkness and pressure. Ice cores extracted above contain trapped gases and ancient atmospheric traces. Earth preserves entire ecosystems in frozen isolation, providing windows into environments resembling distant icy moons. Chapter 40. Along mid-ocean ridges, new crust forms continuously as magma rises from the mantle. These underwater mountains stretch around the planet like a seam. Hydrothermal vents along the ridge support life using chemical energy instead of sunlight. Organisms thrive on sulfur compounds, demonstrating alternative biological pathways. Earth constantly rebuilds its surface through quiet seafloor spreading, renewing crust piece by piece in the deep ocean. Chapter 41. Across the Andes, scientists found ancient ash layers containing glassy shards that trace supervolcano eruptions long forgotten. These microscopic fragments record eruption intensity, wind directions, and atmospheric chemistry from thousands of years ago. Some shards traveled across oceans, settling far from their source. They preserve snapshots of past climates and volcanic cycles. Earth scatters these tiny records quietly, allowing future researchers to reconstruct events once erased from memory. Chapter 42. Underneath Earth's crust, superheated water circulates through fractures, forming vast geothermal systems. These fluids dissolve minerals, deposit metals, and shape underground landscapes without ever reaching the surface. They create natural reactors where chemical gradients support microbial life. Seismic surveys reveal interconnected pipes of heat flowing through rock. Earth runs these hidden thermal engines continuously, influencing volcanic activity, crust formation. Chapter 43. Giant underwater dunes shift across the seafloor, shaped by deep currents moving like slow rivers. Some dunes reach heights taller than skyscrapers, forming wave-like patterns invisible from the surface. Sonar mapping reveals their migration over years, carving channels and altering ecosystems. These structures show that even in darkness, the ocean floor is dynamic. Earth reshapes underwater landscapes steadily, using currents we barely understand. Chapter 44. Ancient lava tubes in Hawaii and Iceland continue for kilometers underground. Some contain rare mineral growths formed from vaporized metals settling in thin layers. These tunnels offer stable temperatures ideal for preserving geological records and even past microbial traces. Their shapes reveal eruption styles and lava flow speeds. Earth hides vast corridors beneath volcanic fields, leaving behind natural archives of molten events long cooled. Chapter 45. Earth's mantle plumes rise from deep boundaries where solid rock slowly behaves like fluid. These plumes fuel volcanic islands, causing long chains of eruptions across geological timescales. Seismic imaging shows columns of warmer material extending thousands of kilometers upward. They shift and pulse over millions of years, altering crust behavior. Earth stores immense thermal forces underground, releasing them through slow, rhythmic upwellings. Chapter 46. Some lakes flip their water layers in seasonal turnovers. Warm water sinks while cold water rises, redistributing oxygen and nutrients in sudden shifts. These flips can trigger fish die-offs or intense plankton blooms. Sediments at the bottom hold chemical clues about past turnovers. Earth uses these natural mixing cycles to reset aquatic systems, maintaining balance through temperature-driven rearrangements. Chapter 47. Meteorites found in Antarctica contain ancient minerals older than the solar system. These grains formed around dying stars long before Earth existed. Their isotopic patterns reveal star explosions, dust clouds, and early cosmic chemistry. The ice preserves them perfectly, concentrating them in specific regions. Earth holds extraterrestrial relics in frozen deserts, giving scientists direct samples of processes that shaped the universe billions of years ago. Chapter 48. Along continental shelves, massive underwater landslides, called submarine slumps, carve enormous scars. These events displace sediments rapidly, sending turbidity currents racing through deep valleys. They can trigger tsunamis without surface warning. Seafloor mapping reveals layered deposits, recording past collapses. Earth reshapes coastlines through hidden movements, storing geological risks in slopes that shift silently beneath the waves. Chapter 49. Earth's crust contains natural nuclear reactors that once operated billions of years ago. At Oklo in Gabon, uranium-rich rocks produced self-sustaining reactions moderated by groundwater. These natural reactors ran intermittently, leaving behind isotopic signatures. They prove that nuclear processes can occur without human influence. Earth experimented with atomic energy long before civilization, storing remarkable evidence of these ancient reactions in stable rock formations. Chapter 50. High in the stratosphere, Earth forms thin layers of noctilucent clouds made of icy crystals glowing under sunlight. These clouds appear at extreme altitudes where temperatures are near the coldest on the planet. Their formation hints at atmospheric changes and water vapor shifts reaching unusual heights. Satellites track their movements to monitor climate trends. Earth paints shimmering signals in the upper atmosphere, revealing subtle transformations in global air patterns. Chapter 51. Deep below Europe, seismic scans revealed a massive fragment of an ancient continent called Greater Adria. It was once the size of Greenland before being dragged under the Eurasian plate. Only small remnants remain at the surface. The rest lies buried as a folded slab stretching hundreds of kilometers. Earth stores these sunken landmasses beneath active mountain belts, preserving pieces of continents lost to tectonic collisions. Chapter 52. Earth's deserts sometimes produce mysterious sounds known as singing dunes. When sand grains slide together at specific sizes and humidity, they create deep humming tones. Each dune has a distinct pitch, like natural instruments shaped by wind. These vibrations travel through the ground, revealing internal dune layers. Earth uses simple friction to generate resonances, turning silent landscapes into unexpected acoustic systems. Chapter 53. Some volcanic islands rise and disappear within years. Underwater eruptions build soft cones that erode quickly once exposed to waves. Satellite data shows these islands forming and vanishing across the Pacific. Their short lives record volcanic pulses hidden beneath the ocean. Earth constantly tests new landmasses, allowing temporary worlds to emerge briefly before being reclaimed by the sea. Chapter 54. Beneath South America, the subducting Nazca Plate releases water into the mantle, generating magma pockets deep below the Andes. These fluids change melting points and create distinct volcanic chemistries. The Andes' diverse minerals reflect these underground interactions. Earth uses water locked in ancient oceans to fuel mountain-building processes, transforming buried crust into volcanic arcs over immense timescales. Chapter 55. In polar regions, cracks form long, geometric patterns called ice polygons. They emerge as frozen ground expands and contracts with seasonal temperature changes. These shapes reveal thermal stress patterns and hidden subsurface conditions. Some polygons record climate variations reaching back thousands of years. Earth draws geometric signatures across frozen terrain, allowing scientists to read past temperature cycles from these natural diagrams. Chapter 56. Deep inside caves, delicate formations called speleothems grow as mineral-rich water drips slowly. Their layered structures capture chemical fingerprints of ancient rainfall, droughts, and atmospheric shifts. Some stalagmites preserve centuries of data in a single column. Earth writes climate records in these slow-growing stones, providing one of the most precise archives of past environmental changes. Chapter 57. Earth's oceans absorb massive amounts of heat, storing it in deep currents that move slowly around the planet. These currents act like conveyor belts, distributing thermal energy globally. Temperature sensors show centuries-long cycles influencing climate far from the source. Earth uses its oceans as thermal regulators, quietly smoothing temperature extremes and stabilizing long-term weather patterns. Chapter 58. In granite formations, scientists found microscopic fluid inclusions containing primordial water billions of years old. These tiny pockets preserve early chemical conditions, offering clues to Earth's first oceans. Their isotopic signatures show how the planet cooled, formed crust, and stabilized its hydrological cycle. Earth stores the oldest remnants of its water inside crystals that survived deep geological recycling. Chapter 59. Under the African Rift Valley, the continent is slowly splitting apart. Magma rises to fill whitening cracks, forming long lakes and new crust. GPS data shows steady movement as valleys deepen yearly. This process mirrors early stages of ocean formation. Earth is quietly building a future sea, reshaping Africa through gradual stretching of its lithosphere. Chapter 60. Earth's atmosphere traps tiny cosmic particles called muons, which pass through rock more easily than X-rays. Scientists use them to image pyramids, volcanoes, and hidden chambers deep underground. Muon scans reveal voids and density differences without drilling. Earth becomes transparent under this technique, allowing researchers to see structures once considered unreachable using natural cosmic radiation as a mapping tool. Chapter 61. Beneath the North Atlantic, researchers discovered a massive freshwater reservoir trapped under the seafloor. It formed when ancient glaciers melted and freshwater seeped into porous sediments, later sealed by marine layers. The reservoir stretches for hundreds of kilometers, holding enough water to rival major lakes. Earth hides entire water systems below oceans, preserving remnants of past climates in places no one expected. Chapter 62. Earth's deepest earthquakes occur so far underground that rocks should behave like warm putty, not shatter. Yet quakes strike more than 600 kilometers down. Scientists think sudden mineral transformations release intense energy, causing deep ruptures. These quakes reveal hidden reactions inside high-pressure zones. Earth stores powerful mechanical stresses in regions where solid rock behaves unpredictably under extreme conditions. Chapter 63. Ancient stromatolites, built by microbial mats, still grow in a few coastal areas. These layered structures once dominated early Earth, shaping oxygen levels and early ecosystems. Their growth patterns preserve seasonal cycles, tides, and atmospheric chemistry from distant eras. Modern stromatolites act as living time machines. Earth keeps these relic communities alive as reminders of life's earliest architecture. Chapter 64. Large blue holes in the ocean hold stratified layers of water with unique chemical signatures. Some contain hydrogen sulfide zones where sunlight cannot penetrate. These isolated water columns trap biological and geological records unchanged for centuries. Sediments at the bottom reveal hurricane cycles and sea level shifts. Earth preserves detailed environmental histories inside these quiet vertical oceans carved into limestone. Chapter 65. The Pacific Ring of Fire hides massive magma pathways connecting volcanoes across thousands of kilometers. These conduits interact through pressure changes, causing eruptions to influence distant systems. Seismic waves reveal pulses traveling through the crust, linking events across regions. Earth operates this vast volcanic network silently, with deep connections shaping surface activity far more than once believed. Chapter 66. Earth's rotation wobbles slightly in a motion called the Chandler wobble. It shifts the poles by small distances over 433-day cycles. This wobble comes from fluid motions in the oceans and atmosphere interacting with Earth's elastic crust. These tiny shifts affect global weather patterns subtly. Earth exhibits delicate rotational rhythms, showing how interconnected its internal and external motions truly are. Chapter 67. Below deserts in the Middle East lie fossil aquifers formed during ancient wet periods. They store water from eras when the climate supported rivers and grasslands. Today, these aquifers remain sealed beneath thick layers of sand and rock. Their chemical composition reveals old rainfall patterns and atmospheric conditions. Earth preserves these hidden reservoirs as evidence of drastically different environments from the distant past. Chapter 68. Some islands drift over time due to tectonic movement and sediment buildup. The Mississippi River Delta shifts its landforms as sediments accumulate, creating new islands while old ones erode away. Satellite images show these transformations unfolding like slow-motion maps. Earth constantly redraws coastlines through natural sediment cycles, reshaping habitats and water routes without human involvement. Chapter 69. Earth's mantle contains diamonds formed under extreme pressure. Some diamonds carry tiny mineral inclusions, revealing ancient mantle chemistry. A few even contain traces of water deep within crystal structures. These gems act as geological messengers brought up by volcanic eruptions. Earth hides these high-pressure minerals deep below until explosive forces deliver them to the surface as fragments of inaccessible regions. Chapter 70. Large regions called shadow zones form in the ocean where sound waves cannot travel due to temperature and pressure gradients. These gradients bend sound upward or downward, creating silent pockets used by marine animals for navigation. Submarines once relied on these zones for stealth. Earth shapes acoustic pathways underwater, influencing how communication and detection occur in the deep sea. Chapter 71. Under the Himalayas, seismic imaging shows massive pockets of partially melted rock trapped between colliding plates. These zones flow slowly, acting like lubricants that influence how mountains rise. Their chemical signatures reveal recycled ocean crust buried long ago. Heat from these pockets affects earthquake patterns and crustal thickening. Earth hides dynamic layers beneath towering peaks, storing molten remnants of ancient seas inside one of its youngest mountain ranges. Chapter 72. In northern Europe, huge ancient river systems lie buried under glacial deposits from the last ice age. These paleo valleys once carried powerful flows shaping the continent's landscape. Radar mapping reveals their twisting paths still preserved underground. Some valleys now guide groundwater movement, influencing modern water supplies. Earth keeps these old drainage networks intact beneath sediment layers, preserving evidence of powerful rivers that vanished thousands of years before. Chapter 73. Earth's upper atmosphere contains a region called the thermosphere, where temperatures can soar above 2,000 degrees Celsius despite thin air. Solar radiation excites molecules, creating rapid heating invisible from below. Satellites orbiting in this zone feel atmospheric drag that changes over solar cycles. These fluctuations affect global communication systems. Earth hides this extreme thermal layer above the sky we see, showing how sunlight shapes atmospheric behavior far beyond clouds. Chapter 74. In deep limestone regions, rivers disappear into underground channels and re-emerge kilometers away. These karst systems form intricate networks of tunnels shaped by acidic water dissolving rock over millennia. Tracer studies reveal hidden routes carrying minerals and nutrients through entire regions. Some passages host isolated species adapted to darkness. Earth builds vast subterranean waterways beneath quiet landscapes, allowing water to follow secret paths that surface maps. Chapter 75. Ancient lava flows sometimes create magnetic anomalies frozen in stone. These anomalies record the direction and strength of Earth's magnetic field at the moment the lava cooled. By mapping them, scientists reconstruct continental drift, plate rotations, and magnetic reversals. Some anomalies reveal unexpected field behaviors that challenge current models. Earth stores these magnetic signatures in hardened rock, providing precise snapshots of past geomagnetic states over millions of years. Chapter 76. Glacial erratics, huge boulders stranded far from their origin, show how ice sheets once carried rocks across continents. These stones reveal the direction, speed, and thickness of ancient glaciers. Some erratics come from mountain ranges hundreds of kilometers away, transported by slow-moving ice rivers. Their mineral makeup preserves evidence of climates long gone. Earth scatters these giant markers across landscapes, leaving clues of powerful frozen forces shaping the planet. Chapter 77. In tropical regions, peat swamps store immense amounts of carbon in thick, organic layers. These deposits form slowly as plant material accumulates in oxygen-poor conditions. Core samples reveal past rainfall patterns, fires, and vegetation changes. Peatlands act as massive climate regulators, holding more carbon than many forests combined. Earth hides these natural archives beneath dense wetlands, preserving environmental histories that stretch back thousands of years. Chapter 78. Earth's crust contains deep reservoirs of supercritical water, fluid that is neither liquid nor gas. Found near magma chambers, this water dissolves metals efficiently, driving mineral formation. Its unique properties affect volcanic pressure and eruption timing. Drilling projects occasionally encounter these extreme fluids, revealing temperatures and pressures rarely observed. Earth maintains these supercritical zones as hidden chemical reactors, influencing both volcanic behavior and mineral depot. Chapter 79. Under Greenland's ice sheet, radar scans revealed an ancient impact crater buried beneath kilometers of ice. It measures over 30 kilometers wide, formed by a meteorite that struck millions of years ago. The impact reshaped regional geology and may have influenced ancient climate cycles. The crater's structure remains preserved by ice, acting as a frozen record of cosmic events. Earth hides this massive scar beneath one of its coldest surfaces. Chapter 80. Along ocean trenches, slabs of crust bend and crack as they descend into the mantle. These fractures allow seawater to penetrate deep into the earth, triggering chemical reactions that release hydrogen and other gases. These reactions support unique microbial life within the rocks themselves. Earth hosts these hidden deep biospheres at subduction zones, allowing tiny organisms to survive in extreme conditions far below the ocean floor. Chapter 81. Beneath the East Antarctic ice sheet, scientists found entire mountain ranges buried under several kilometers of ice. These peaks, called the Gamburtsev Mountains, are as tall as the Alps, yet completely hidden. Their valleys contain ancient sediments, revealing early glacial history. Radar imaging shows sharp ridges preserved by constant freezing. Earth conceals full-scale continents beneath ice, storing landscapes untouched for millions of years. Chapter 82. Some coastal cliffs display rhythmic rock layers formed by ancient sea level cycles. These tidal bundles preserve daily tidal patterns from hundreds of millions of years ago. Each thin layer represents a single tide, allowing scientists to estimate the number of days per year in deep time. These rocks show that Earth once spun faster with shorter days. The planet quietly embeds its orbital history into coastal sediments. Chapter 83. In volcanic regions, carbon dioxide seeps from deep faults, creating zones where plants mysteriously die. These moffetts reveal active degassing long before eruptions occur. Gas sensors track subtle changes that help forecast volcanic behavior. The chemistry of these emissions reflects magma depth and temperature. Earth releases quiet warnings through invisible gases, offering early signs of movement deep below the surface. Chapter 84. Ancient coral reefs now sit high on mountaintops due to tectonic uplift. These fossilized reefs contain detailed chemical records of sea temperatures and ocean chemistry from millions of years ago. Their structures reveal past sea level changes and evolutionary patterns. Earth lifts these marine worlds into the sky, preserving ocean histories far above their original environments. Chapter 81. Deep under Antarctica's oldest ice, sensors detect faint tremors that don't match normal glacial movement. Some scientists think they come from hidden lakes shifting under extreme pressure. Others suggest unknown geothermal vents. Whatever the source is, the signals repeat in patterns, almost like a slow heartbeat. Earth keeps reminding us that its coldest places are alive in ways we still can't fully map or predict. Chapter 82. In the Pacific. Researchers found a stretch of seafloor coated with tiny metallic spheres older than the continents above them. These micronodules hold clues to Earth's early chemistry, formed when ancient seawater met volcanic heat. They're like time capsules scattered across the abyss. Touching one is like brushing against the first spark of our planet's long memory, locked away in darkness for billions of years. Chapter 89. Some mountains contain metamorphic rocks that formed under extreme pressures miles beneath the surface. These rocks carry mineral structures that only develop at great depths, then rise through tectonic uplift. Their compositions reveal ancient plate collisions and subduction events. Earth exposes deep processes by lifting these transformed rocks upward, offering glimpses into regions usually hidden far below. Chapter 90. Along the ocean floor, bacteria create vast carpets of white filament networks stretching for kilometers. These mats feed on sulfur compounds rising from sediments. Their growth patterns reveal chemical gradients and ocean floor activity. Some mats shift locations as seafloor conditions change. Earth nurtures these silent microbial landscapes in darkness, shaping deep ecosystems through chemical interactions rather than sunlight. Chapter 87. Desert varnish, thin, dark coatings on exposed rocks, forms at extremely slow rates through microbial activity and mineral deposition. These coatings contain trace elements and isotopes, revealing environmental changes over thousands of years. Some patterns match ancient rainfall fluctuations and dust cycles. Earth writes slow environmental narratives on rock surfaces, using chemical films that take centuries to form. Chapter 88. In polar ice cores, scientists find trapped volcanic ash layers from eruptions worldwide. Each layer marks a precise moment in history, allowing synchronization of climate records across continents. Gases within bubbles reveal past atmospheric compositions. These vertical archives hold continuous timelines spanning hundreds of thousands of years. Earth preserves detailed climate diaries frozen inside its coldest regions. Chapter 91. Deep inside old mountain ranges, scientists found rocks containing trapped droplets of ancient seawater. These droplets are so old, they predate most modern life. When analyzed, Their chemistry reveals how Earth's oceans tasted billions of years ago. More acidic, more mineral-rich, almost alien. It's a quiet message from a world long gone, preserved inside stones that never forgot. Chapter 92. In the Amazon, patches of land show unnaturally dark, fertile soil called terra preta. It wasn't created by nature alone. Ancient civilizations engineered it by mixing charcoal, bones, and microbes. The soil still regenerates itself centuries later. While the forest hides their cities, the land remembers their science, proving humans once knew how to work with Earth, not against it. Chapter 93. Beneath the Sahara, satellite scans reveal the ghost of a gigantic ancient river system. The desert once held flowing water wide enough to reshape continents. Now, the channels lie buried under dunes, hidden from view but clear from space. It's a reminder that Earth's greatest transformations often happen slowly, leaving behind traces only visible when technology catches up. Chapter 94. Some mountains emit faint, natural radio signals caused by stress deep in their faults. As the rocks strain and shift, minerals generate electric currents that travel upward. These signals don't predict quakes, but they show Earth constantly releasing tension like a giant mechanical clock. We're only beginning to decode these whispers from the planet's moving bones. Chapter 95. Scientists studying deep-sea vents found microbes living entirely without sunlight, powered only by chemical reactions in scorching water. These organisms rewrite our understanding of life, showing that biology doesn't depend on the sun. They survive where pressure could crush submarines. If life can thrive here, it raises the question of what might exist on other worlds with similar oceans. Chapter 96. Ancient meteorite fragments buried in Antarctica contain rare isotopes not found naturally on Earth. These tiny pieces likely came from exploded stars, traveling millions of years before landing in frozen silence. Scientists call them stardust, and studying them is like holding a piece of cosmic history. They remind us that Earth is constantly catching gifts from beyond the solar system.